we take a look at section 6.4 here, we're going to look at solving compound inequalities. These inequalities are going to be a little bit more difficult than what we've been doing in class. So hopefully at the end of this video you feel pretty confident. So first of all, what is a compound inequality? Simply put, it's two separate inequalities joined by the word and or. So it's two inequalities thrown in as one. Okay? The and statements are written as one inequality. The solution is where the graphs overlap, okay, and it's called the betweenness problems, okay? And so an example of a compound inequality would be something like, if I do, let's just say, -7, whoops, try this again, there we go, -7 is less than or equal to 2x plus 1 is less than 6. Okay, so it's written as one giant inequality. There's three different things there, but it's all written as one inequality. And we'll look at how to solve that here momentarily. Or statements are written as two separate statements separated by the word or. Graphs do not overlap, and arrows point out away from each other. So I could say 2x is greater than 6, or 2x is less than -6. And when you solve those, you're going to get two separate graphs going opposite directions. So hopefully this will make more sense as we just start working through things. So number one says translate the verbal phrase into an inequality and then graph the inequality. So it says all real numbers that are greater than or equal to -2 and less than 2. So that means we're going to write it as one big inequality. So -2, we are bigger than or equal to that, but we got to be smaller than 2, so we're between those two numbers. So if this is -2, this is -1, 0, 1, and 2. Now you graph it the same way you would any other inequality. So first, look at this part of the expression. It says -2 is less than or equal to x. That means go to -2, put a closed circle, and there I'm going to shade everything to the right. Okay? To the right. X is bigger than that, so we got to go to the right. For the second part of it, if I just isolate this part, it says x is less than 2. So when I go to my graph, I go to 2, I put an open circle, and I shade everything to the left. Okay? So now you're sitting there probably saying, well, wait a second, that graph looks kind of funny. Well, what you end up doing is really the correct part of the graph that you were looking for is strictly the part of the graph where these two things intersect. Okay, so the correct part of the graph would just be this portion here with a closed circle at -2 but an open circle at +2. And so if I say graph it, exactly what you see on the screen there is what I'm looking for. Part B says all real numbers that are less than or equal to 3 or greater than 6. So there's two separate ones here, or. Okay, so x is less than or equal to 3, or x is greater than 6. So I go to 3. Let's call this guy 0, 1, 2, 3, 4, 5, 6. So I go to 3, put a closed circle, shade everything to the left, that's less than. And then I go to 6, put an open circle, shade everything to the right. So there's two separate graphs essentially on the same number line pointing in opposite directions. And then part C says all real numbers that are greater than -8 and less than or equal to -3. And so it's an and, so it's one big one. So you have -8. Our numbers are bigger than that or less than or equal to -3. So really what I do is I go to -8, I put an open circle. So let's call this guy -3. That'd be -4, -5, -6, -7, -8. So I put an open circle at -8. A closed circle at -3, and then connect the two. All right, and that's how we're going to graph our and inequalities. All right, number 2 now we're going to get into solving and graphing, and this is really where the bulk of the information is that we're going to be concerned with. So 2 part A says 15 is less than or equal to 3x minus 3 is less than 24. And so I solve this inequality just like I've been solving all of the other inequalities so far in this chapter, with the exception of now when I add 3 to the middle one, I have to add 3 to every single one. Okay, and so this guy becomes 18 less than or equal to 3x less than 27. I got to get x by itself, divide by 3, So I got to do every single thing. 18 divided by 3 is 6, less than or equal to x, less than 9. And so now when I want to graph this thing, if this is 6, 7, 8, and 9, I put a closed circle at 6, open circle at 9, and connect them. Okay, this is an AND inequality. Okay, one big one. All right, part B, no different. Okay, just going to go ahead and start solving this thing. So we're going to subtract 1 from every single one. So 15 minus 1 is 14, less than negative 7x, less than 49. Divide every term by negative 7. Our rule still applies that if we multiply or divide everything by a negative, we have to flip the inequalities. So I have negative 2 is bigger than x is bigger than negative 7. So now I go to negative 2, call this guy negative 2. Negative 3, 4, 5, 6. This guy here would be negative 7 then. I have 2 open circles, and then I just connect those guys, and there's my graph. So again, no different, except now we're going to add or subtract from 3 different things. Okay. I'm going to let you guys go ahead and work on part C on your own. That's another AND inequality. That's the same way that we just did A and B. Okay, and as always, if you have a question on it, have it ready to go in class. Part D here. Okay, so I have 2 separate ones. I'm just going to solve them separately. So I look at the first one. I subtract 6. I get 5x less than or equal to negative 15. Divide by a positive 5. So x is less than or equal to negative 3. Or, now I come over to this guy and solve this one. Okay, so I have 2x is greater than 20. Divide both sides by a positive 2. X has to be bigger than 10. So either x is less than or equal to negative 3 or greater than positive 10. Okay, and so I'm going to call this guy negative 3, close circle, shade everything to the left. And then if this guy over here were positive 10, it would be an open circle, shade to the right. Again, any OR inequalities, you're going to have 2 separate graphs that point in opposite directions. Part E is no different. Okay, just obviously some different numbers we're working with here. So add 2 to both sides, you get 3x less than or equal to negative 9. Divide both sides by 3, x is less than or equal to negative 3. Or subtract 8. 2x is bigger than 8, divide by 2. So x is bigger than 4. So I have 2 separate ones here, graph them separately. So call this guy negative 3, close circle, shade to the left. Negative 2, negative 1, 0, 1, 2, 3. I don't have enough. This guy would have to be 4 here. It's an open circle, shade to the right. Okay, so that's how you solve ORs. You solve them independently and then graph them independently. So I'm going to go ahead and let you guys look at part F. Again, it's just like the previous 2 examples we did. Try it. Any questions? Ask in class. And then the last example here is a story problem. It says at an auction, the lowest bid for an autographed trading card is 20. The highest bid is 54. Write and graph a compound inequality that describes the possible bids. Okay, so the lowest one is 20. Okay, so we can be equal to that. The bid is somewhere between 20 and 54. Okay, so if we graph this thing, call this thing 20, call this guy 54. Obviously, we're not going by scale here. We're just doing it for argument's sake. Since they're both equal to, they're 2 closed circles, and since it's a combined inequality, it's one big one, we're just going to shade the region between those 2 points. So, again, this section's probably a little bit more confusing and maybe not as straightforward as what we've been doing. So, any issues you have, bring them up in class, and we'll make sure that we resolve and clarify any misconceptions.